In this example, we're asked to write each expression as a single logarithm. So in example 2, you may recall, we were going from a single logarithm and splitting into multiple logarithms. This is the reverse. So we're going from multiple logarithms, multiple logs, and we want to combine into a single. So these are the reverse. But the same rules will allow us to do that. If we have a difference, like in part A, a difference of two logarithms, we know that if we can combine them together into one logarithm by taking the quotient of their arguments. Now before we jump to that rule though, we may observe there's a 2 in the front of this logarithm. In order to use the rule where we can combine them, we have to remove this 2 in the front. So we're going to use the reverse of the rule that allows us to bring the exponent in the front. We're going to move it back up. We're going to move this 2 back up to the exponent of the argument. So we can rewrite this as log base 3 of u squared. Now we have a logarithm and an argument, a logarithm and an argument. They both have a base 3. So I can subtract, which allows us to combine these into one logarithm, and we take the quotient, u squared over v. So we went from 2 separate logarithms and combined into one. Okay, I'd like you guys to try part B on your own. I'm going to jump to part C here next. Okay, so on part C here, we've got actually 3 logarithms, 3 natural logs, base E, and we want to combine all these. So we've got a sum, these are being added, and then we're subtracting. So let's go 2 at a time. I don't recommend trying to go from 3 directly to 1. I would recommend pairing up 2 of them and then pairing up 2 more. So let's look at the first 2. Natural log of x over x minus 1 plus natural log of x plus 1 over x. So if I want to add 2 logarithms, I can combine them into one by taking the product of the arguments. So I can rewrite this as natural log of x over x minus 1 times x plus 1 over x. So I'm taking the natural log of that product, and let's just leave this third logarithm here alone for now. So now I want to multiply x over x minus 1 times x plus 1 over x. Well, we can see that those x's are going to divide out, so that makes this a little simpler. So we divide an x into both of these, so we're just left with 1 in the numerator here and the denominator here. So now if we simplify our argument, this becomes the natural log of x plus 1 over x minus 1. And then I'll bring down my natural log x squared minus 1. So once we join together the first 2, now we can combine this resulting logarithm and then the natural log x squared minus 1. So even if the help me solve this or view an example or the e-textbook suggests that you combine these all in one step, I would recommend doing it in 2 at a time. Okay, so now we have a difference, so we can use division to combine these together. So now I want to take the natural log of the quotient, x plus 1 over x minus 1, and I want to divide by x squared minus 1. Well, when I divide, that's the same as multiplication by the reciprocal. So rather than doing this division of a fraction, let's change it to multiplication by the reciprocal. So now we can see this x squared minus 1. This can factor. This is a difference of squares. So I can rewrite this as x plus 1 over x minus 1 times 1 over, and that x squared minus 1 will factor into x minus 1, x plus 1. So we have a common factor in this numerator and this denominator, so we can divide that out. So we can divide x plus 1 by 1 and get 1, and divide this x plus 1 by 1 and get 1. So now that argument will simplify into 1 times 1 in the numerator, just 1, and in the denominator, we've got x minus 1 here and x minus 1 here. So we can rewrite that x minus 1 squared. Now that's useful because we want to write this argument using an exponent if possible. So I've got an exponent on the denominator of the argument, but we know if we have a reciprocal, we can rewrite that 1 over this using a negative exponent. So I can rewrite this as the natural log of x minus 1 to the negative 2 power. So now I've got that power up on the argument, and I can move this out into the front and multiply. So I'll take my negative 2, move it out into the front, and then finally we have negative 2 times the natural log of x minus 1. So when you have 3 or more logarithms, you probably won't have many more than 3. I would definitely pair up, do 2 at a time, combine 2 into 1 first, and then combine the remaining 2. I think that's an easier way to do these. And then I'd like you guys to try part D on your own, please.